Alright, in this video we're going to start chapter 8, which is our study in hypothesis testing. And there's a whole lot of vocabulary in here, and so I'm going to start out by saying you need to read your book. I say that all the time. I think after the last test maybe it'd be more clear how much you guys need to spend time with that. And I'm going to touch on some of the vocab here in these videos, but I'm not going to dwell on them. So you need to read them, you need to try to interpret them, you need to talk to each other about them, and if you don't know what the words mean, you can't figure out what it's saying, then you need to come see me. Okay. So in chapter 8, we're going to start again with hypothesis testing. So when we talk about a hypothesis, a lot of you have maybe heard that word from a science class or somewhere else, but it's really just it's an educated guess. Okay. That's not how your author defines it, but it's still, however you want to word it, just an educated guess. He uses the word conjecture, which means guess, or it kind of, in the educated sense, about a population parameter. Okay. So we have studied the parameters of mean, the population standard deviation or variance. We have talked about the population proportion in the last chapter, and I think those were the main things that we've talked about. In every hypothesis test, there are two hypotheses. There is the null hypothesis, and there is the alternative hypothesis. Okay. The null hypothesis is symbolized, let's see how many tools I can get going here all at one time, is designated with a subscript. We have H sub 0. The alternative hypothesis is either written as H sub A, or in our book, H sub 1. Okay, so we've got H naught, is how I'll say it, or H sub 0, okay, or H1. Okay, other authors, other books might call it H sub A. The null hypothesis is the one that states that there is no difference between the parameter and a specified value. Okay. Or no difference between two parameters by the time we get to the end of chapter 8. I don't know why my little pin is blinking. Hope it doesn't give anybody a seizure. Okay. The alternative hypothesis is the rest of the story. Okay. It states that there's a difference and usually specifies how it's different from the parameter that's in question. When we're looking at our null hypothesis and our alternative hypothesis, the null hypothesis for us in the first handful of sections, we're going to build pretty much in the same order that we built in the last chapter with our confidence intervals. Okay. Our null hypothesis is going to be that the mean of our population is equal to a number. Okay, that the mean ACT score is 1,000, that the mean height on our basketball team is 6'3", or on a basketball team of all basketball players, okay, population. The alternative hypothesis is going to be that this mean is different from that number. Okay, there are three ways we can say that it's different. We can say that we believe that mean is less than the number in the null. We can say that it's greater than the number in the null, or we can say that it's not equal to that number in the null. Okay. Those are our three options. If then we're looking at some statements here. It says the average age of community college students is 24.6 years. Okay, maybe this is the hypothesis that we are trying to test. Okay, when we are creating our null hypothesis, the null hypothesis is always has the equal sign in it. So our null hypothesis is that mu is equal to 24.6. Okay. If that's all it tells us that we're testing, we're not saying, oh, I believe it's really students are older than that or younger than that. Okay. If it doesn't give us anything specific, then our alternative is that the mean is not equal to. Okay, so we're just testing, is the mean 24.6 or is it something else? if I'm testing the statement, the average age of attorneys is greater than 25.4 years. For my null hypothesis, the null hypothesis always has the equal sign. And the value that I'm given, that I'm testing against, is that 25.4 years. If I want to test the hypothesis that the average age of attorneys is greater than that, okay, then my alternative hypothesis is that mu is greater than 25.4 years. On the third one, if we want to talk about the average resting pulse rate of male marathon runners, we are checking to see whether or not we believe, or whether or not we feel like it's less than 70 beats per minute. Our null hypothesis is that mu is equal to 70. Okay. Our alternative, since it says less than, will be that mu is less than 70 beats per minute. Okay. So we can set up the null hypothesis is always, in our case, it'll be mu for the first few, but whatever our parameter is, that mu is equal to, or sigma is equal to, or p is equal to the number that's given. The alternative is either going to be not equal to that number, greater than that number, or less than that number, depending on what we're given in the problem. Okay. In the next video, we'll talk about what we call each of these situations and what to do from there.